Welcome members to TED Talks. You're still with me, Mugwanya Simon, and we shall be going together in biology, and we are still looking at chemicals of life as far as proteins are concerned. Now we can go further and look at a special protein which we are calling enzymes. Very vital molecules which we cannot deal away with, because when they become denatured, as we discussed, even life ceases to happen. So what are enzymes? If you are to define them, what are enzymes? In simple terms, we would say enzymes are biocatalysts, protein in nature. So we are dealing with a protein. That means enzymes are made up of carbon, hydrogen, oxygen, and nitrogen, sometimes even sulfur atoms. Those are present in enzymes by the virtue of the fact that they are protein in nature. This means a lot. Bio, which we already discussed, that bio means life, and they are catalysts, meaning they do a lot in life processes. So let's further and say properties of enzymes. Or somebody can go further and say characteristics of enzymes. We have already said some characteristics in our definition, and they still hold. The first one, which we can derive from here, we can first of all say are produced by living cells. This is very crucial, because when we die, our cells cease to produce enzymes, and that's the main cause of death. They are produced by living enzymes. Then from here, we can go further and say alter the enzyme, the reactions, alter the rate of the reaction. That would be the definition of a catalyst, that all catalysts alter chemical reactions, the rate at which chemical reactions occur, either by speeding up chemical reactions or by reducing the rate of a chemical reaction. Number 3, of course, we can bring the next part of the definition, that they are protein in nature. They are protein in nature. Then the others can come along. We can continue further and say enzymes work best at optimum temperature. Enzymes work best at optimum temperature. We shall go further and expand this. Why do they work best at optimum temperature? And what's the effect of temperature on the rate of the enzymatic activity? 4. Enzymes work best at specific pH ranges. So as enzymes are working, we shall also go further and see the effect of pH changes on the rate of the enzymatic reaction. Number 6, can also say enzymes work best in smaller quantities. They work best in smaller quantities. Meaning, we are also going to see the effect of enzyme concentration on the rate of the enzyme controlled reaction. If they work best in small quantities, what happens when enzymes are very many? That will be expanded. Then 7, enzymes catalyze reversible reactions. Enzymes catalyze reversible reactions, meaning those reactions that can, an enzyme that maybe controls the union of A to give you C can also catalyze its breakdown to give you A and B again. So they catalyze reversible reactions. 8, enzymes can be inhibited by some factors. So enzyme activities can be inhibited by some factors. We shall expand it further and see the effect of inhibitors on enzymes. When they give you a poison, how does that poison kill you? And lastly, enzymes either work within cells or outside cells. We shall see several examples where enzymes work within cells and others work outside cells. So with this, we know now what enzymes do. Enzymes are biocatalysts, meaning they control all living processes which take place within cells or outside cells, so long as they are that. Then they are proteins. That's why we have paid attention to them as special chemicals of life under enzymes. Then we can now briefly talk about naming of enzymes. Naming of enzymes. In most cases, the naming of enzymes, biologically, when we find an enzyme, a word that is ending with a suffix called "-s", we can conclude that one might be near to an enzyme. Then the prefix this way can tell us which substrate does that enzyme catalyze. We forgot one thing which we can even put it here. Enzymes are specific in nature. Why are they specific in nature? We had earlier discussed that proteins take up different functional structures. So that functional structure of a protein makes it very specific in what it does. The way it coils around gives the enzyme the specific nature. Because now they are specific in nature, we can now say, while naming them, we can bring in that you want to see an enzyme that works on carbohydrates. Collectively for us, we shall now say all enzymes that work on any carbohydrate can be grouped as carbohydrases. We group them together and say those are carbohydrases. So we shall receive many carbohydrases, amylase enzyme, maltase enzyme, sucrase enzyme. Those are collectively called carbohydrases, meaning those are specific to glycosidic bonds. That's what they catalyze. Then an enzyme that works, let's say, on proteins, we shall classify them at once and say those are proteases. But we have several proteases because there are very many types of proteins as we talk. We have peptides, dipeptides, and even polypeptides, among others. Then we have lipids. Enzymes that work on lipids as organic substances, we shall just call them lipases. So meaning when you find this suffix there on a word, and you know what this one means, that this one is carbohydrate, that means that one is a carbohydrate. That might be an enzyme that works on carbohydrates. Proteins, proteases, it means it works on that. Lipids, lipases. So to generalize, enzymes are named like that, but some exceptions are there when you find the substrate that is being worked on by the enzyme does not resemble the name that goes in it. Give you some exceptions. A few exceptions. So exceptions in the naming. Exceptions in the naming. You find that, let's say, proteins in digestion. Let's say you find when the enzyme is trypsin from the pancreas. You find when the enzyme is pepsin from the gastric glands. So the naming there does not rhyme, yet they are also working on proteins. But collectively, trypsin and pepsin will come back to this bigger group and say these are proteases. So in our next sessions, we shall now go back, expand this further. We first look at the different kinds of enzymes. How are they named? How does an enzyme get a name? According to the reaction and even according to the area of operation.